but let's get into our pattern. So today what we're going to have a look at is different ways to represent relationships between numbers. So what we looked at on Monday is just looking at a list or sequence of numbers and being able to identify what the pattern is between those numbers. Now, what we need to be able to do in number patterns is look at that list of numbers and be able to find a rule that applies to those numbers. And so that's sort of what we're going to start chatting about today, and we'll carry on chatting about next week. So what we have here is a flow diagram. Some people love flow diagrams, some people hate flow diagrams. I quite like them because it really breaks down the rule, or it really breaks down the operations that you're performing to your values. And I always think about a flow diagram like a number machine. You've got some numbers that you're going to put into this machine, which we call our input numbers. Now, input values we can represent with an X. And we do something to those numbers. That's where my machine part comes in. I perform a whole bunch of operations, and then I get some sort of answer. And this is what we call our output. Now, the output value can be represented with a Y. So sometimes we use X and Y in number patterns. And so that is how I think of a flow diagram. It allows me to apply some sort of rule to my input values in order to essentially express the relationship that exists between those values. All right, so we're going to have a look at this first one together, and then you're going to try some by yourselves. If we start with an input value of -3, so remember, this is my number machine. I'm putting -3 into my machine, and the first thing that's going to happen to it is I'm going to add 4. So if I start with my first input of -3, I'm adding 4 to it. Now, hopefully we remember from our integer section how to do this. -3 plus 4 gives me 1. So I've done my first operation, and then moves along the machine, and I now need to apply the second operation, which is multiplying by 2. So I take that answer of 1, I multiply it by 2, and I get my final output value of +2. So that is what my flow diagram is allowing me to do. It's allowing me to apply this rule, whoopsie daisies. It's allowing me to apply this rule to my input value in order to get an output. So if I now have a look at my second, I'll get there eventually, at my second input value, which is -1. My -1 goes into the machine. I add 4, so -1 plus 4, which gives us 3. And then we say 3 times 2 to give us our output value of 6. And so we keep applying our rule to our input values in order to get an output value. So I want you guys to find for me the output values of the input values of 0 and 4. So those last 2 inputs that I have there, I want you to take them. I want you to apply the rule that we've been given. So exactly the rule given in the flow diagram. And I want to know what your 2 output values are there. You can pop them in the chat. So this will be A, and this will be B. So you can put your answers A and B in the chat, just that we know which is which, seeing as I'm asking you for 2. Sorry, Latish, I numbered them a bit late. So apply your rule and figure out what those outputs should be.
Let's go, my people. You're putting A equals 2, B equals 2, okay? So we can see which answers you answering. So if you don't number them, we might not see. Y'all are doing really, really good, my people.
Guys, remember the rule with hands. We only raise hands when I say so, either for questions or for answers, only when I say so. If you've got answers, as we've told you, put them in the chat. Or if you've got questions, put them in the chat. Or send Yolanda or myself a message. I'm just going to give everyone another minute or two to finish up. Alrighty, so now at this point, if anyone would like to raise their hand to give me an answer, I'd like you to do so. Wonder Wonke, give me the first one. So the output for the input of 0.
Yes, ma'am. Ma'am, 0 plus 4 is 4, and then
Good.
4 times 2 is 8.
Excellent. So our output here, guys, is 8. Perfect. I'm just writing the operations down there for those of you who might need it. Excuse me. Melissa, help me out with the last one. Oops. There we go.
4 plus 4 times 2 equals to 12.
Okay, so let's just double check. So our last input, we've got 4 plus 4, which gives us 8. And then we want to say 8 times 2, which gives us 16. So really close. Well done. Good try. Our output there is 16. Excuse me. All right, so guys, we need to be able to apply this. Please, can we all just calm ourselves? I'm going to get to how we write formulas, how we write general rules. We're just starting off slow. I promise you I'm going to get there. I'm not just going to leave you hanging. We will get there. Right, so take your screenshots. Everyone with hands up, you need to put them down, please. Right, so I want you to try the second one by yourselves. So you've got your input values here. I've listed your input values down on the left-hand side. Remember, this is represented by X. I want 4 output values from you. So A, B, C, and D. Apply your rule as given to you in your flow diagram. And I would like 4 output values from you. And then we'll chat about how we can get a rule as Oratile has asked.
Remember, my people, we need to say A and writing it on our book, B, C, and D on our book, and then we're going to transform those answers into the charts, okay? But first, find out every single answer, okay? Don't just give us A on the chart. Find out every single answer, write it on your book, and then say A equals to, B equals to, C equals to, D equals to on the chart. Okay, my people, just like Shumi there. Well done, Shumi, you did it. Okay, I'm not saying that your answers are 100% correct, just saying that the way you've put the answer is nice. Singita, you need to put A, B, C answers, okay? Don't just work out A and then put it on the chart. Work out all A and B, put it on your book first, and do the working out on your book, and then you can give us answers, okay, guys? Y'all are doing really, really great. Melissa, you must listen to the rules. Leva, listen to the rules. I don't want A answers only. I want A, B, C, and D. Well done, Teto. That's A, B, C, and D. That's how we need to give our answers. Toy, you need to write your answers again. Avevuso, you need to write your answers again. Well done, Limyolim Toa. Well done. So yeah, you need to write your answers. Remember, don't work it one by one because you forget them. When you work them one by one, it shows to me that you only putting your answers on the charts and you did not write them on your book, and that's not a good thing. Well done, Hitesh, Lisa, well done. It's not a good thing. Don't work it out one by one, guys. You forget, by the time that we're doing corrections, you forget what you wrote for A or for B. Then you can't correct your work. Well done, guys. Rialeboha, I see you. Well done. Tatenda, well done. There we go. Now we got our rhythm. Rotondo, you have to start again. Well done, Chantel. Well done, Lizua. Well done, Avevuso. Well done. Well done, guys. Now we're listening to the instructions. Well done. I'm so proud of you.
Okay, guys,
There
very
we go.
nice. So if you would like to raise your hand to give me an answer, now's the time to do so. Right. Oh gosh, sorry. Right, Bonolo, first one.
Hi, ma'am.
Hi.
So, ma'am, I said -2 times 3, which give me -6.
Good.
Then I said -6 minus 1, which give me -7.
Perfect. Well done. Okay, so guys, our first one there is -7. I just want to run through that again because we need to be careful of our signs. -2 times 3 is -6. If I then say -6 minus 1, I'm taking 1 away from something that's already negative. So it has to get more negative, hence the -7. So just be very, very careful with your signs as you go along. Okay. Lemoli, oh, sorry, I didn't say your name very well. Let me try that again. Lemolimtwa. Where we B.
B, I said -1 times 3, then give me -3. Then I said -3 minus 1, give me -4.
Perfect. Well done. So guys, again, we need to be careful of those signs, but exactly we get -4. Relebocha, do you want to do C?
Afternoon, ma'am.
Hi.
I said 1 times 3 equal 3, and then -1 equal 2.
Perfect. Well done. Okay, so guys, there we didn't need to be as careful with our signs, but we always need to take note of our signs. We never want to make a silly mistake with our signs because we don't want to lose silly marks. Lizman Kobo, no, you've disappeared. Okay. Takalani?
Hi, ma'am.
Hi.
Ma'am, I said 3 times 3, which is 9.
Good.
And then 9 minus 1, which is 8.
Perfect. Well done. Okay, so guys, just remember 3 times 3 is 9, not 6. Just bear that in mind. But exactly as Takalani said, 3 times 3 is 9, minus 1 is 8. Right, very nicely done. Let's remember to lower our hands. Right, but now we're going to have a discussion around what Orotile asked earlier of how do we go from this to a rule? Oh, excuse me. Okay, so what we almost need to imagine here is when we want, actually, let's take a step back. If we want to have a rule for our pattern, our rule entails our y equals and then something to do with our x value. Basically what it is an algebraic equation to describe our pattern. So if you have a flow diagram, it actually is quite useful because now what you can almost imagine is if you had any input. Now, we can't decide what that any input should be, so we represent that with an x. And now we can apply our flow diagram. So remember, the whole point is to apply our diagram or apply our rule, and we're going to get y. So in order to get y, in order to get that output, I need to say x times 3. Now, if we say x times 3, we know we get 3x. And then I need to subtract 1. Now, remember, these are not like terms, so we can't actually go and subtract them, but we can leave our expression as it is. And so what this is telling me is that in order for me to get an output of y, I need to say 3 times my input minus 1. And so with the flow diagram, finding a rule becomes a lot easier for us because then we just apply that rule to our input or a general input of x. Excuse me. We will discuss how you can find a rule without a flow diagram. Sometimes you might want to draw a flow diagram to help you. But if you are given a flow diagram, essentially what we're doing is we are taking any input. So this X represents any input I want. Could be 2, 20, 40, 10 million, whatever. Any input, what is the rule I apply? And so I'm able to get an algebraic equation to describe that rule. All right, so I'm going to wait in case anyone wants to take a screenshot again. Please remember to take your screenshots, guys, especially with all the flow diagrams and eventually when we start doing tables and stuff. All right. So what I want from you in question C is I want the 4 outputs here. So let's go A, B, C, and D again. And if you finish really quickly, you can try find the algebraic rule. So the rule, like what we had here. Okay, now while people are getting started on that, if there's any questions, I would like you to raise your hand now. Otherwise, you are finding those 4 outputs. And if you're really quick, you can try and find the algebraic rule. Otherwise, again, if you've got questions, you're welcome to raise your hand at this point. Oh, no questions. Okay, so guys, the only thing I'm going to say is just remember, be careful of your signs. Make sure that you are always taking into account what sign it is that you are working with. Because, again, where we go wrong is generally a silly little sign somewhere, and we don't want to lose silly marks. Remember, like Yolanda said, put your answers in the chat as A, B, C, and D. Try and do them first on your book before you start giving us answers. So do all 4 of them, and then you can give us all 4 answers at the end once you've got all 4 answers. And remember, if at any point you have a question about what's going on, you're welcome to raise your hand, as I've said, because now is the time to raise hands. Or you can pop it on the chat for us and we can help you there. Okay, question?
I want to ask if you use BODMAS.
Okay, so very important question. Guys, in this case, we don't use BODMAS. We just apply the rule in the order that we have been given it. So the first thing that we do is we add 1. The second thing we do is we times by 3. And the third thing that we do is we divide by 2. So in a flow diagram, we don't apply BODMAS. Good question. Well done. Okay, these hands better be for questions. You under Pale?
Ma'am, I just wanted to ask, ma'am, how do you find, like, because I get confused with the rules, ma'am. How do you find, like, the algebraic rules?
Okay, so like I explained in the last example, if you've got a flow diagram, you just apply the flow diagram. We're going to do it with this one as well, so you'll see. However, if you don't have a flow diagram, it is a little bit harder, but we're going to do an example just now where we don't have a flow diagram and how we find our rule from there. And so hopefully that'll also make a bit more sense. But if you've got a flow diagram, you literally just put X in as your input, you apply your rules, and then you get a rule or an output according to your rule. Okay, Cornelia, I don't think you can hear me. It looks like there's an audio issue. Okay, good. Well done, you guys, on doing your questions and putting your 4 answers down in the chat. I'm going to give everyone another minute or so, and then we'll have a look. Good, Ashley. Keep those answers coming, guys. Right, hands up if you'd like to help me with these answers. Lesejo?
Yes, ma'am.
Okay, first one.
For the first one, I said -5 plus 1, which gave me -4 times 3, which gave me -12 divided by 2, which gave me -6.
Excellent, well done. Guys, I hope you all heard that. That was beautiful. Oh, my negative is weird. That was beautifully explained. So this is -6. Sorry, I just put my whole hand over the camera because I was trying to steady my laptop. Anywho, again, there's a negative there. So -5 plus 1 is still a -4. And then when we times a negative by a positive, we still end up with a negative. So you needed to be careful with your signs. Tohira, second one. Should be the pop-up. There we go.
Hi.
Hi.
So I said 0 plus 1 equals 1, multiplied by 3 equals 3, divided by 2 equals 1.5.
Excellent, well done. So guys, B was a little bit of a trickier one because you ended up with a fraction. So either you write 3/2, or you can write that 1.5, or if you're the person who likes mixed numbers, you can write 1.5. Any of those is absolutely fine. It was a slightly tricky one. So Tohira, very nicely done. We ended up with a fraction there. Good. Nkululeko, see? Nkululeko, you there?
Ma'am.
There we go.
Yes, ma'am. Ma'am, the answer for C is 3 plus 1 is 10 divided by 2. That gave me 6.
Perfect. Okay, sorry, I had to catch up there. Right, so guys, 3 plus 1 is 4. 4 times 3 is 12. 12 divided by 2, 6. Excellent, well done. We've got so many hands. This is awesome. Well done. Zimi, do you want to do the last one? Oh gosh, sorry, I'm just unmuting all the people. Zimi? Zimi Mandla? Okay, right. If you see pop-ups for unmutes, just ignore me. Ria Kanse?
Then 7 plus 1 is equal to 8, and 8 times 3 is equal to 24. So 24 divided by 2 is equal to 12.
Perfect, well done. So guys, exactly 7 plus 1 is 8. 8 times 3 is 24. 24 divided by 2 is 12. Very nice, well done. All right, so I said if you finish really quickly and we want to try the algebraic rule, which I see Lunufe first tried there on the chat. I'm going to do it with you though. We can try and find this algebraic rule here. Now, remember what I said, when we want the rule, what we do is we take any value of X, any input value, and we represent that with X, and we apply our rule. So the first thing that we do is we say x plus 1. Now those aren't like terms, so I can't do anything with them. The next thing that I need to do is I need to take that x plus 1 and I need to times it by 3. Now remember, one way to represent that is with a bracket. So we're saying 3 times whatever x plus 1 is. So again, whatever that answer of x plus 1 is, we're timesing it by 3. That's what my rule says. And from there, I then need to take whatever that answer is and I need to divide it by 2. So now I need to take my 3 times the x plus 1 and I need to divide the whole thing by 2. And that will give me my output. So that will be equal to y. So this rule is a hard rule. That's why I say try it, because I would never give you something like this right to start off with. But this is our algebraic rule. We first add 1, then we times by 3, and then we divide by 2. And so this goes back to the question of following BODMAS. We don't follow BODMAS. We need to then make sure that our rule correctly orders or puts in the correct order of work the plus 1 first, then the times 3, then the divide by 2. And that's why those brackets are so important. All right, so that was a hard rule. I didn't expect you to just get that straight away. That was just, if you had the time, you could give it a try, but that would be your rule for this flow diagram. Right, so take your screenshots, and then I think it's time for a break. Just waiting for everyone to get screenshots, giving everyone some time. Rightio, hopefully we've got that. There's our brain break. I feel like I gave you this brain break on. I did give you this brain break. I'm just losing my mind, guys.
You
It's all
did.
fine.
You did
Yeah.
give it to us.
So please ignore that brain break and let me keep losing my mind because I don't know what on earth is going on here.
And it's okay. We don't have to have one. Also, we can stretch more people. Yeah, and keep stretching wherever you are. Relax your mind. Okay, I think like we're getting on off with this work quite nicely. So, and I'm loving it. I feel like we've done that one also.
We did it with the other class.
Now with
Guys,
this one.
Have we done this one? I'm pretty sure we
It's
did the
familiar.
Ken on Monday. This one we did with the first class on Monday, but we didn't.
Oh, yeah, it could
Yeah.
be. That's why it's familiar to me.
Yeah. Okay, so guys, there's your brain break. I want you to try it. It's not that Ken, it's this bad boy over here. The calculator, yeah. I love cows, so every now and then I do throw in a cow joke. Righto, so you're trying this. We want that final answer. Remember, we want the final answer for the final equation right down here at the bottom. It's a weird looking square, but anyways. Woo! Sorry, everyone. She still works. Right, remember your order of operations. Remember to do multiplication first and then only addition. Order of operations is important.
We can do this, my people. I'll tell you when someone has the correct answer. I'll definitely let you know. Melissa, you must put your answers on the chat. We want the final answer, okay? So by giving a crayons equals to 6, it might be helping other people. Doesn't matter, but I am looking for that final end product. What is the final answer, my people? Nope, Melissa is not 90. It's not right. Teto is not 125. Let's keep trying. It's not 166. Nope, Nundu. I'll let you know. The first one to get it right before the long weekend. Yes! Sissy Paul got it right. Sissy Paul, can you please raise your hand? Litesh, you might lower your hand down, my sis. We are looking for Sisipo. Sisipo, you can raise your hand so you can explain to us how did you get the correct answer. Yes. Oh, okay. Let's do this. Sisipo, explain to us. Take us through.
So for the pencil,
Uh-huh.
I said 30 divided by 3, and then I
Yes,
got 10.
girl. Yes, girl. That's correct. And what
So
did you
then
do next?
I know the other pencil is 10.
Yes, girl.
So then I said, what did I say again?
Do you need some help? There's other people I think who got the same answer. Spumelelo, you can raise your hand up so you can come help. Luno, raise your hand up. Mutebang, raise your hand up. Leva, raise your hand up so you can help. Sisipo, I'm not ignoring you. I'm just looking for help for you, okay?
Yes, ma'am.
Muteba, do you want to help? I'm going to unmute you, Sisipo. I'm going to mute you for a bit. And let's see what Mutebang says. Mutebang, what was the next step? What did you do?
Ma'am, I think the crayons, there are 6.
Good.
Okay, so what did you do to get 66?
So I asked myself 10. So it's 66. So I said 10 times 6. It must be 60, and then plus 6 will make 66.
Yes, my guy, got it. Do you want to continue? What about the next line? What did you do?
Yeah, ma'am, can somebody continue, please?
Yes. I'm gonna get back to Sisipo. And remember those names that I Lisedi, you must raise your hand also. Who else was it? But for now, Sisipo, do you wanna give it a try? Another go? Leva, you must raise your hand. Luno, you must raise your hand. But I see Chantal is also here to come help. So Chantal, do you wanna unmute and help?
Yes, ma'am.
Okay, what happened? What happened to the third step? What did you do?
Ma'am, the crayons, I said 6 plus 6 is equals to 12.
Yes, girl.
And I said the crayons, so I thought that the crayons were 5 plus 5, which is equals to 10.
Okay.
Mm-hmm.
And then I said, and the other ones are 10. So
Nice.
12 times 10 is equals to 120 plus 10, which is equals to 130.
Yes.
Excellent.
And the last step, do you want to give it a try?
No, ma'am. Yes, ma'am.
Don't worry, Chantal, you really did well. Teto, I'm going to come to you. Do you want to give us the last step? You are doing really well. Let's go, Teto.
Hello, ma'am. Can you hear me?
Hi.
Yes, ma'am. When I was doing my stuff, I ended up saying 5 plus 12 times 10 instead of 10 plus 12 times 10. But so with the crayons, there's 2 crayons at the bottom. So it's 12, not 6. So it's 10 plus 12. And then with the paint brushes, there's also 2. And since 1 is 5, it's 10.
But so how did you get your answer?
Ma'am, with bond mesh, you have to go with multiplication first.
Yes!
So I said 12 times 10, and then I added the 10 at the end.
Yes! And you got how much?
130.
Yes! Done! Y'all nailed it. Well done, Teto. Well done, everyone. I would like everyone to now lower your hands down, okay? This was a very nice brain break. Well done, my people. I'm so proud of you. Let's get back to maths. Let's do this.
Well done, guys. Alrighty, so yes, very nicely done for there. sorry, my words are gone. Right, so what we're going to have a look at is looking at tables and how we can get from a table to potentially our rules. And this is what I was saying earlier, that if I give you a flow diagram, it's quite nice and easy to get a rule. It's when we don't have a flow diagram that lays out step by step what our rule is that we need to think a little bit harder. All right, so remember I said to you that your input is your X values, your output is your Y values. So if you think of it in terms of your flow diagram, these are the numbers you put into the machine. These are the numbers you get out of the machine. That is input and output. Now, what we can also say is that our input is our term, I'm going to call position. Okay, so basically what that means is input of 1 is your first term in your pattern. Input of 2 is your second term in your pattern. Third, fourth, and so on. Okay, so that is what the X represents. It represents which number in the pattern are you looking at. The Y value then represents the value of the term. So, for example, if we look at this 3 here, this is saying that the value of the first term, because X is 1, is 3. If we look at this output here, this is saying the value of the fourth term, because X is 4, is 0. Probably write that there as well. Right, so that is what our X and Y represent if we now relate it to like a list of numbers, a number pattern. Now, the first question is asking us to describe the pattern in words. So we need to figure out, how am I getting from 3 to 2 and then from 2 to 1? What is the pattern in my outputs? So if I have a look at this, from 3 to 2, I subtract 1. From 2 to 1, I subtract 1. From 1 to 0, I subtract 1. So my pattern is that we subtract 1 from the previous term to get my next term. So we're subtracting 1 each time. All right, so when we're describing in words, remember we want to essentially describe what we're doing from one output to the next so that our pattern continues. That now means that I can fill in my missing values. So I want to fill in my missing values for the inputs of 5, 6, and 7. So I just carry on my pattern. I subtract 1 and I get -1. I subtract 1 and I get -2. I subtract 1 and I get -3. So because I know what my pattern is, I can continue it. The next question then asks us to draw a flow diagram to represent the pattern. Now that's all well and good, but I need to actually know what I'm doing to my input value to get my output value. And this is now where sort of finding a rule becomes quite helpful to us. Okay, so if we've got our pattern, I'm just going to rewrite our pattern. So our pattern is 3, 2, 1, 0, -1, and so we keep going. I don't need to write all of it. Okay, and we've identified the fact that this pattern is us subtracting 1 each time. I subtract 1 to get from one term to the next. So the hint that we need to sort of take away from this is that clearly this subtraction of 1 is quite important because that remains constant throughout the pattern. That is very important. And so the little trick that we can use is that if we now want to find the rule, we start with, because we know it's going to be y equals 2, and we start by multiplying x by whatever we add in or subtracting. So I'm going to say -1 times x. That's where we start, okay? And you're going to see why in our later lessons, why this is the case. But that is sort of our first point of starting where we are. So if I now go back to my table and I start with an x value of 1, if I times that by -1, so if I say, sorry, there's so many colors here. If I say my input value of 1 times that -1, I get -1. But my output that I want is 3. So I need to ask myself, okay, how do I get from -1 to 3. What should I add or subtract to -1 to get 3? Well, I know that if I add 4, I'm going to get 3. So let's put that in there and see if this works. So now we want to check if our rule works for all of our inputs. Now we're going to do a quick check for ourselves. So if I now take my input of 2, so x equals 2, I need to get an output value of 2 according to my table. So let's see. 2 times -1 is -2. -2 plus 4 is 2. That's perfect. That is the output value I wanted. Let's check another one just to be sure. So let's take our input value of 3. 3 times -1 is -3. -3 plus 4 is 1. Perfect. That is the output value I wanted. And what you will see is that this rule now applies to all of my input values. So if we just take a random one, if we took 7 and we said x equals 7, 7 times -1 is -7. -7 plus 4 is -3. That is correct. So by looking at my input and how I get from the input to the output, I have found a rule. So now we can take this rule and we can translate it to a flow diagram. We'll get there in the end. So we take our input, we put it into our number machine. The first thing that we do is we times x by -1. I'm just putting it in brackets, you don't have to. And then we add 4 to that product. And that gives us our output. That gives us our y value. Okay, so this is why I said to you earlier, when we're not given a flow diagram, it does make it a little bit harder for us to know what the pattern is. But when given a table, we can always look at what our input and output values are, so the x and the y, and we can establish what the relationship between our output values is in order to then eventually go and find our rule. Right, so I'm going to stop here for a screenshot. I'm also going to stop here if anyone has any questions, because that was quite a bit of information that I just gave you. So if anyone has questions, now's the time to raise your hand and ask. Sorry, apparently I'm just opening a whole bunch of random things here. Any questions, grade 8s? Oh, okay, good. I'm glad to hear that. Specifically?
Ma'am, I don't understand how you did the sum.
Which sum?
I think it's the pattern, ma'am. On the table, ma'am, the pattern.
Okay, so basically what I did was I gave you, let's just take some of this off.
No, you.
So I gave you the first 3. So I told you these first 3 outputs. So you can almost take it out of a table if you want. So what you could do is you could take these numbers out of the table and you can say you've got a pattern of 3, 2, 1, 0. So what we want to do is we want to figure out what that pattern is. And what I see is that each time I'm subtracting 1. And so that means I can carry on that pattern. I can now say 0 minus 1, which gives me -1.
-1.
Exactly. -1 minus another 1 is -2. -2 minus 1 is -3. So I looked at the pattern in my output values and I decided, how do I get from one term to the next?
Okay, ma'am.
Okay. Right, guys, again, you're saying I'm lost, I'm confused, I don't understand. I need to know specifically what, otherwise I can't help. So I don't understand the flow diagram. Perfect, I can help with that. Melissa, I hope you are following me at least up and like for this rule. So I hope you agree with my rule here. All I'm doing is I'm now taking my rule and I'm putting that into a flow diagram. So the first thing that I did to x was I times it by -1. So I take my input and I times it by -1. The next thing I did was I added 4. So I take whatever that answer is and I add 4. And when I do all of that, that gives me my y, my output. So all I'm doing is I'm taking the rule that I got and I'm translating it into the flow diagram. I'll come back to this now. If we go back to what we did here in question B, that's exactly how we got our rule. We took our flow diagram and we translated that into a rule. We started with an input of x. That x was then multiplied by 3, and then we subtracted 1. So all we're doing now is we're going from the pattern, getting a rule, and putting it into a flow diagram. Right, I hope that makes a bit more sense. I hope we've all taken screenshots of this.